Morning. So in the last lecture, we have seen the importance of maintenance. The various types of maintenance also we have seen. So first we should know what is the breakdown maintenance. And then we should know predictive maintenance. And then we should know what is planned maintenance. So unless otherwise you maintain your equipments properly, there is going to be a quality problem. Then we have seen the 6 big losses. So once again, quickly we will see the 6 big losses. And then there is one important parameter, overall equipment effectiveness. Or in this slide, it is shown as equipment effectiveness. So how do you find out that equipment effectiveness? And we have 3 metrics. One is availability law. Second one is performance efficiency, and the third one is quality. So all these things quickly we'll go through. And the next, in today's lecture, we will see about Kaizen and 5S. So these are the overall goals of total productive maintenance. So we should maintain and improve the equipment capacity. It should be available all the 24 hours. So maintaining the equipment for life, using support from all areas of operation, encouraging input from all the employees, and then using teams for continuous improvement. And these are the 7 steps in total productive maintenance. The first, senior management is very important. They should learn the new philosophy. And the second point, it should be promoted. And then third one is training. That is very important. When you want to do maintenance, you should know anything. So for example, somebody is a secretary, means they should be trained in the printer. So some small things they can do instead of calling the maintenance person. And the areas of needed improvement are identified, performance goals, and then performance goals are formulated, and implementation plan is developed, and then work groups are established. And 6 major losses are there. So first one, there are some planned losses. And you know very well, continuously 8 hours you cannot run the equipment. There has to be some gap has to be given. For example, beginning of the mission. So we have to switch on. So sometime it is going to take shift change. So normally 8 p.m. to 4 p.m. one shift will be there, and then 4 p.m. to second shift will start. So whenever there is a shift change, so naturally there will be some loss of time. That is going to be availability. Availability, mission is not going to be available. So that is these are all planned loss. These are all called downtime losses. And the coffee and lunch breaks have to be given. And then planned maintenance shutdowns. And sometimes, there are some missions. For example, if you have a furnace, they have to be maintained. So sometimes they will not be available. So maybe 2 days completely they will do the maintenance. So those 2 days, so these are all planned. It will be the downtime. It will be there. And the second one, unplanned downtime. So the equipment, there is a breakdown in the equipment. So it is unplanned. Then changeover. Material is not available. This is a common problem in industry. Machine will be there, worker will be there. Sometimes some material will not be available, so the machine has to be idle. So this is unplanned downtime. So these 2 classes come under availability. So the total time, there is a total time, and these has to be subtracted. Yes, subtracted only. So we can find out what is the percentage of available time. That's what we are going to see in the problem. So total time will be there. You know what is the total time, and then you subtract all these downtime. You will get that is the time available. That divided by total time will give the availability. And then reduced speed losses. There are some reasons, idling and minor stoppages will be there. Different reasons stoppages will be there. And the slowdown. So this is an example, late example, or even bus. Even take a bus more. Normally the bus cannot run to the maximum speed. The reason is if there is vibration. Deliberately, the driver will drive the bus at a lower speed just to avoid vibration. So this is called a performance efficiency. So anything we cannot go for 100%. Even in case of lathe also, even in our lathe also, whatever we have in lab 001, the maximum speed is around 1500 RPM. We never go for that because vibration, all these things will be there. Always 90%. So these are all called speed losses. So this is called performance efficiency. And finally, we have the quality losses. So process non-conformity is defects. So it is always, you cannot avoid that. There will be some defective products. However, quality, whatever we are having, there are different reasons. Operator may be some mistake on operator side, material defect will be there, equipment defect will be there. Some defects will come. So that defects, these things, because it's a quality loss, and then scrap, wastage, whatever wastage. So these are the 6 big losses. And downtime losses, they are measured by equipment availability. So availability is given by the operating time, which is planned time minus downtime. So that example I did, planned time, we have to subtract the downtime, you get the operating time. That divided by the planned operating time will give the availability. Basically, for some time machine is available. For 8-hour shift, for example, it's 8-hour shift. We are running, for example, we are running for 5 days. Into it, 40 hours is available. In downtime, some minutes or some hours will be there. So you subtract them, that is going to be the operating time. That you divide by the planned operating, then you will the availability. And usually the number will be 80%, 75%. So we should aim for 95%. Of course, overall equipment efficiency, we have to aim for 85%. And you know very well, 100% is very ideal, not possible. Because even planned maintenance, planned downtime is there. Reduced speed losses are measured by tracking the performance efficiency using the equation. So E is efficiency, performance efficiency, which is equal to C into N by T, where C is the theoretical cycle time. So cycle time is not the actual machining time. Cycle time is nothing but the time required to make a product. What you know, in 1 hour, how many products you can make. So that's for individual product. So that is called theoretical cycle time. That you multiply by the processed amount, total quantity what you are making, and then you divide it by. So this numerator is going to be time, because cycle time is in minutes. N is a quantity, that is a number. You multiply them, you will get minutes. And this T is nothing but the planned time, planned operating time, So we have seen the previous step. So that is also in minutes. So you will get efficiency as a number. And normally this has to be around 90%. 90% is a good number. 90 to 95 is a good number. And the third comes the rate of quality products. R means 0. So E means efficiency. So poor quality losses are measured by tracking them. The quality losses are measured by tracking the rate of quality products. So this is very straightforward. The processed amount is N. Q is non-conformity, that means defects. So N minus Q divided by N will give the rate of quality products. So N is the total number. Q is the defects. So you will get the what you call non-defective products in the numerator. N is the total products. So that will give the rate of quality products. And equipment effectiveness, some of the textbooks, they use the word OEE, overall equipment effectiveness, which is given by A multiplied by E multiplied by R, where A is the availability, E is the performance efficiency, and R is the rate of quality products. And this target should be 85%. Typically, we have to aim for 85%. And as I told you, you cannot go for 100. Everywhere, some defects will be there. Performance 100%, some speed losses will be there. And availability, sometimes the equipment will not be available. So 85% is the target. Your target should be 85%. And all the maintenance program, whatever you are planning, should be whatever goals you should try to aim for. When you implement all the TPM techniques, it should come around 85%. So now this is an example. So 10 hours per day, and we are having 5 days per week. Everything we are going to do for week, we are going to do this. Theoretical cycle time is given. Production Q N is given. Production 4,450 is given. Defective parts is given 15. First, the planned time. Planned time is given by whatever time. This time, planned time is nothing but. So how do you get this 3,000? So 10 hours a day into 5 days. So into 60 minutes, we are multiplying by 60. So 10 into 5 into 60. So because why we are having minutes is all the downtime they are given in minutes. There are two downtime minutes. One is due to manufacturing, other is due to maintenance. Last class we have discussed. So 410 plus 2 to 27, you can add them. 637 minutes. The machine is not available. The equipment is not available. Whereas the total minutes is 3,000. So how do you get that? 10 hours a day, 5 days a week, 60 minutes per hour. So we are getting 3000 minutes per week, and the downtime is 637 minutes. So you subtract this 3000, we subtract the 637, you get 2363. That you divided by 3000, 2363 divided by 3000 will give the availability. So very obvious. The total time is 3000 minutes, and the downtime 637 we are subtracting, so we are getting 2363. That divided by the total time will give the availability. So A is 78.8%. The next E is nothing but C is the cycle time. The cycle time is 0.5 minutes per product, 0.5 minutes, and then is the total number. We are making 4,450 products. So 4,450 into 0.5. So this numerator is in minutes. So 0.5 is in seconds. So for one product, the cycle time is 0. The cycle time is that is for one product always. So cycle time is 0.5 minutes. That you multiply by the total quantity what you are producing, which is 4,450 divided by the time. Divided by the time will give the efficiency. So this is ideal. Theoretically, 0.5 into this much minutes it must take, but actually due to the availability is only this much, so the efficiency is 94.2%. Next, the R is the rate of quality products. So rate of quality products is nothing but number of products what we are making minus Q is defects. Non-conformity means defect divided by N. So 4,450 minus 15 is the defects, non-conformity, minus 4,450 divided by 4,450, so which is 99.7% is the rate of quality products. So now all these three we are multiplying. So 0.788. So equipment effectiveness is nothing but 0.788 multiplied by 0.942 divided by 0.997. So you are going to get 0.75. So equipment effectiveness is 74%. But I told you the target should be 85%. So we have to adopt some strategies, TPM techniques, so that the equipment effectiveness. So that's what the 7 steps I told you. You have a philosophy, maintenance, you have some goals, form autonomous groups. All these things you do so that you bring it to 85%. So that is about TPM. Now we'll go to the next chapter, Kaizen. So this is Kaizen is a Japanese concept. So we have in the syllabus Kaizen and 5 years. We will try to cover in this lecture. So what is a Kaizen? So in Japanese, Kai means change and Zen means good. And the Kaizen means good change. So the main idea of Kaizen is to make a small change. Only thing is it should be a good change. And it should be for better, and it should be continuous improvement. Small thing what we are doing. So for example, in this class, I want to improve it. So some small thing I should do so that, for example, if I am going to teach something over and above the syllabus. So an example, Kaizen I gave when I was working in some other college. They asked me, you should give some Kaizen, some improvement. So what I tell them, what I said is, I am going to teach one topic which is over and above the syllabus. So there is a syllabus for this subject. So that is going to be a good change, small improvement. So something is not there in the syllabus. I am trying to teach students so that they will be benefited. So like that, no? K means change, and it is should be for good. Small, and it will not be great. Suddenly overnight, nothing. Dramatic improvement will not be there. Dramatically. So for example, the last class, last 5 minutes, we have seen the equipment effectiveness is around 75%. Overnight, within 10 days, you cannot make it 85%. It's going to gradually we are going to. So some small incremental changes we have to plan, and then we have to make it better. Again, I'm telling you once again, this Kaizen always focuses on the small and quick changes. Very quickly you must implement. That is going to be important. Keep on thinking, planning. That is not it. So you must, whatever improvement you have decided should be small. Quickly you must make so that there is a continuous improvement. Kaizen means, in other words, it's a continuous. That's what everywhere TQM. Continuously we have to make some improvements. And elimination of 8 wastages. So anyway, everywhere there are going to be some wastages. Anything waste means it should be avoided. So that adds to the cost. So that 8 types of waste I will show in the coming slide. So Kaizen is rapid improvement in a particular work cell, workstation, small process, factory location, office, anywhere it can be work cell. Anywhere you make a rapid quick small improvement. That is Kaizen. Kaizen is not improvements, it's a complex cross-functional or systemic problems where projects are fixed. So whenever the problem is huge means you have to go for 6 months. So that we are going to cover later. So there is a philosophy called DMAIC, define, measure, and other things. So Kaizen is for same thing what we are doing in Six Sigma. Here also we are going to do, but only in case of Kaizen, it is a rapid, small improvement. What are the targets? So eliminate waste. So what is the non-value added activity? This is the best example whenever I teach TQM to understand the non-value added activities. I used to tell them, suppose if you want to go to Tirumala and you want to visit Lord Venkateshwara. So what do you do from Chennai? So Tirumala is around 140 kilometers. So morning you start at 5 o'clock and you have to travel in a train or bus. Then once again you have to go by bus and then you have to wait in the queue. And then you will have the darshan. So, totally, if you start from 5 o'clock in the morning, and definitely by night 11 o'clock, 12 o'clock you can. So totally it comes around 16 hours. So 5 to 5 is 12 hours. 16 to 17 hours you will take total time. But the value addition is the darshan is going to take how much time? You know very well. Tirumala, whatever, not even 5 minutes. If you are lucky enough, no, you will have 5 minutes. So totally, it is going to be 16 hours, 16 into 16. That is the total activity. So inevitably, suppose if we want to do anything, there will be some non-value added activities. So going by bus, they are all essential, but they are not creating any value. The final value is darshan is, so you are going to have the darshan for only, that is the main value added activity. So there are some essential activities which are not adding value, There are value adding activities, and there are some activities which are waste. They are non-value adding activities, they are not required actually, but sometimes they will be there. So in case of Kaizen, what we have to do, we have to identify what are the value added activities. Then next, what are the non-value added activities, but still they are essential. For example, some of the activities, they will be legal. Legally something we have to do that will not add value. Value addition will not be there. But legally we have to do that. So even though it is a non-value activity, it is required. That is the second type of activity. Third is non-value activity, unnecessary activity. So that has to be eliminated. Increase the productivity. So you know the output should be increased. So that is everywhere. Modern industry, you go there, you have to increase. Where you go, increase the productivity means more profit. Reduce inventory, material as well as labor. Unnecessary person should not be there. More number of workers should not, because your profit is going to come down. Even material also, the same output you plan for lesser material. Reduce the cycle time. So this, if you reduce the cycle time, productivity will increase. Next time to produce a specific part. Reduce the space. Even VAT also now, we are trying. Space is not available. VAT, you know very well. Right now there are around 14,000 students. There are so many programs, so many labs. Very difficult to get space in. And you know very well, Chennai, it is one of the next to IIT. I think we are the largest space wise. We have 100 acres. IIT Chennai is 100 acres. Even of course, Anna University also. Maybe first 3 or 4 students VAT, but still we are not having space because the number of students is so. Reduce the workspace to be one of the target of Kaizen. Improve on-time delivery. So many times, if you are not delivering on time, sometimes the orders will be cancelled. So we have to improve the on-time delivery, improve the quality of product and process, improve housekeeping 5S. So we are going to discuss in this same slide I am having 5S. So some of the Japanese words are there. So simplifying and other things. So that we will discuss. Reduce downtime, setup time, maintenance time should be reduced. So that availability will increase. Reduce transport time, material handling time should be reduced. Distance should be reduced. So plant layout. So when we are doing the plant layout now, so we have to be very careful so that the material handling is minimum. Of course, the metal handling has to be done from one machine to other machine. Somewhere the component has to move. Some metal handling is required. So you try to reduce the time, standardize the process. Variation, that was TPM. Variation should be less. Operating cost should be reduced. So try to make all the improvements. So these are all some of the ground rules. Don't accept excuses. Just to say no to we have always done. Think of how it can be done, not why it won't work. Don't make excuses. Ask why 5 times until you get the root cause of the problem. So this is what we have seen in the cost benefit diagram. There is something called root cause analysis also. What is the root cause of the problem? We have to find out. So 5Y, I think this also Netlet is available. How analysis. So team solution is the best solution. In individual, so you have to form a team, then you should have a solution. Don't overanalyze. Understand the process, then just do it. So the case are not don't that is for Six Sigma. Over-analyzing we have to do in Six Sigma. Don't seek perfection. So that's what very important. Even nowadays, no, this generation always seeking perfection in the first time. So that is also not that. So many times, no, ideally we cannot do. So it will take some time, then only we can attain the perfection. Every person has a voice, and there is no such thing as a dumb question. Keep a positive attitude, respect everyone. So these are all some rules. So when you do Kaizen, these are some of the ground rules that has to be followed. And lean production. So this is what we have to eliminate the waste. So whenever there is a waste, no, that is going to add cost. The 8 types of waste we are going to discuss in the coming slides. So we have to eliminate or reduce the waste in all the processes. So that is called lean production. So all these things, I'll tell what are the 8 wastes, then you'll agree. You have to reduce the waste. And please remember, lean production is not about eliminating people. Of course, we are going to see eighth waste is about the creativity of the people. Sometimes the creativity of the people is not being used. But the idea of lean production not to reduce the people, not to eliminate the people. Sometimes if the creativity is being wasted means that is wasted. So don't think reducing people. That is not lean production. So lean production is about expanding the capacity by reducing the cost and shortening the cycle time. So if you reduce the cycle time, naturally wastages will be less. Lean production is about understanding what is important to the customer. So that's what TQM we have been telling. So we have to what is also quality everywhere. We have seen what are the customer requirements. Then we have to focus on the customer requirements. And once again, coming to the value-added activity and non-value-added activity. So what is a value-added activity? An activity that transforms or shapes the product. So any manufacturer is altering the geometry. So for example, if you take casting means you are melting the metal and then pouring into a cavity which is called mold, which will have the shape. For example, if you want to make a piston, you make the cavity of the desired shape, piston shape, and then you pour the molten metal and then solidify. So we are altering the geometry, So an activity that transforms the shape. So casting is a value-added activity or information to meet the customer requirement. So something customer says something, then that is a value-added activity. So value-added is always determined from the customer's perspective. So that is going to be very important. That is what all TQM is all about, total quality management. From the customer's point of view, we have to see whether value addition is there. So I will give an example. For example, if you go to a restaurant, the customers normally will see the surrounding is going to be very important. So that is a value addition. So you provide music or your interior decoration should be very good. Because the restaurant, they will be waiting for some time before they get their dishes. So from many times, the customers, you should provide music, ventilation should be there, lighting should be proper. If it is night means lighting should be proper. So these are all, these things you have to take care. So that will create, basically they are not the basic service. The basic service is going to be the taste of the dosa or idli, whatever you are getting. But from the customer perspective, before getting during the waiting time, you should be comfortable. So that is value addition. That is also value addition. How would you define value for your customers? So these are some of the value-added activities. Now, opposite, what is non-value adding activity? So those activities that take time, resources, or space, but do not add value. This, as we go on, I'll tell you. So it will take time. That's why activity, any activity will take time. It will take time, resources, human being will involve space, everything will be there. So, but it is not adding value. So that is called non-value adding activity. So activities that are performed that the customer is willing to pay. Because no, if it is something is, even if you are giving something, no, many times, especially in service industry, sometimes the customer will not be what the customer will feel that is unnecessary for him. So if you had that activity, that becomes a non-value. Even if you think even it's a value activity, it is all from, especially in service industry, it is from the perspective of the customer. So the activities that are performed, the customer is willing to pay for. So value enabling activities that support value added. So waste means that not contribute to the value addition. Steps that should be considered essential because so value adding activity. What are the steps in? Physically change the product. So any manufacturing is altering the geometry. So that work is going to be the value added. Are done in the right sequence or location. So that's what here movement. One of the waste is going to be movement. So if you are going to move it in the right sequence, and you know very well, all the components you cannot do it in single machine. So we have to do it in several machines. So all the machines, if you are doing it in the right sequence, the material movement, the material handling and transportation will be minimum. If they are not in the right sequence, no, that is wastage of time. So that is going to be very important. That's for you to understand. Suppose if it is a product layout, something that is called product layout, all the machines will be arranged like this. So the machine will go to the first machine, it will go to the second machine, and it will go to the third machine. So there is material handling. Now suppose if it is a process layout, so here some machines are there, here this. All right. So now you just understand. So now rectangle, there are three machines. Assume there are three rectangles. So circular, there are three machines. Triangle, there are three machines. Now the component only out of these three machines, it will use only one machine. Out of these three, it will use one machine. For example, first machine and this machine and this machine. So then if you take, you see the component movement, unnecessary movement is there. So from here to, so the machines are not arranged in sequence. So for example, the product, because it's a process layout, variety of the product is there. So this product goes to this machine, and this machine. So it is not in the right sequence. So product layout will be in the right sequence, but product layout, the variety will be very less. Process layout, whenever the variety is more, you will have process layout. So it has to be done in the right sequence. Otherwise, unnecessary movement will be there. So that is a non-value addition, non-value add. So provide a real and sustainable competitive advantage. So whenever you do that activity, you are having some competitive advantage. So now several things they are doing free, they are giving something free. You buy this, I'm giving free. All these things they are trying to give. So even that creates some competitive advantage is there, that is a value addition. So because your sales improves. Would be seen by the client as delivering the value that seek, and they would be willing to pay for them. So these are all going to be value-added activities. One is whichever is changing the shape, manufacturing activity, whether they are done in the right sequence, whether any competitive advantage is there, customer perceives like that. So these are all called value-added activities. Value enabling activities, steps that should be considered necessary because support company measurement or reporting requirements, reduce risk defect cost, allow subsequent work for the customer to be performed more quickly or accurately, satisfy legal or regulatory requirements, satisfy good business practice requirements. So these you know very well. Reducing the risk means you should do inspection. Reducing the risk defect means you should have some activities. Which customer will feel they are not value-adding activities. It is for you only. So reducing the disk, you are doing some activity. It is not going to add value to the customer. If you want to reduce the defect or if you want to reduce the cost, you will do some activity which the customer, which is not adding any value to the customer. The same way, legal regulatory requirements, legal and there are some legal requirements. For example, environment. So if you have an industry, all the environment requirements. So then if you ask your customer for environment, I am spending so much money, so they will not be willing to pay for that. So these are all value enabling activities. That means they are necessary. Of course, they are necessary, but they are not adding value. That means they cannot be eliminated. The only thing, what is the value enabling activity? Please understand, it is not adding value. It's not adding value, but it is not a waste activity. Not a waste activity. Even though they are not adding value, it's not a waste activity because legal requirements should be there. Environment, whatever environment. So there are some good business practices which you have to do, but they will not add value. So that is the second type. Value enabling, and they are not value adding activity, and they are not waste also. They are required. They are necessary. Waste. So that's what non-value additions. Steps that should be considered non-essential. Do not change or add to the product or service to be delivered. So that activities. So that 8 thing I will show, and then we will stop for this. Are done out of sequence or performed to correct prior actions. Are done out of sequence and are performed to correct the prior actions. Out of sequence means it's a non-value action. So would not be seen by the client as delivering value, and they would be unwilling to pay for that. Sometimes service industry, many times it will be active. So they may say this activity, I don't want this activity. They feel that it is not adding value. So these are all waste activities. So quickly I'll show. These are the 8 wastes. So, Friday's class we will discuss in detail. So one is transportation. I told you the material, unnecessarily the material is moving. So many times this will take place. Material is moving unnecessarily. Inventory. Inventory means store, material storage. Motion, unnecessary motion. Sometimes waiting. So I told you when the line is not balanced, the workpiece will be waiting. Over processing. So there is a demand. Every component there is a demand. Don't produce more than that. So this is the problem in our pending. I think now they would have suffered because in this online atmosphere, still they would have suffered. All Indian companies know who are manufacturing this ballpoint pen. So they have the capacity. Each machine in 1 hour they can manufacture around 45 million or 50 million pens. Actually, there is no requirement in India for that. Because even in the online still, so overproduction should be avoided. Because demand is not there, you will not be able to sell. So that is a waste actually. Underutilized people. So create people. So that is one waste. This is 8th way. So previously there are only 7 wastes. So now underutilized. Someone is not working. So then we say underutilized people. And then defects, of course, is very obvious. So some component is defect means I think one class I told you. Something that is going to add cost. You will not be able to sell the defective product. So you have to scrap it or some reworking you have to. Either way, you have to spend more money. So defect is also a waste. So with this, I will stop for this class. So we will meet on Friday, and we are having one more class this week. I think Saturday, 26th of February, the working day. Friday's timetable.